Hey there everybody, and welcome back to another Blender tutorial. Today we're working on something that is going to be pretty complicated. It's going to be a multi-part series, and it is based on Specular's real-time river generator. So if you haven't seen this, it's been going crazy on Twitter and Reddit and all this. Somebody made a completely procedural river generator using geometry nodes, using shader nodes and all this, and it's gone to the point where you just draw a curve and it does all the river stuff. So it does the foam, the shading, the rocks, everything. So I thought I would do my take on it that you can make for free, but of course this is Specular's idea, so if you want the original, I'm going to put a link in the description for where you can get that for this one. But if you want to learn how to make this for free in a kind of advanced tutorial series, keep watching and I will see you on part 1 of the series. Hey there everybody, and welcome back to another Blender tutorial. We are starting the series for the river generator and this is part 1. So here I put a simple demo together. This isn't the final product, of course, just to illustrate a certain point. What we're going to be generating is basically a curve that is going to make a fancy kind of area for a material to go on, right? So I can extrude this, extend the river, all of this, but the key idea here is we're going to start with a curve and we're going to give it some thickness is the idea, and we're going to do a whole bunch of stuff to that. So in this part, I just want to talk about how do you take a curve and give it a dimension in some sense. So that is part 1, and we're also going to invoke a coordinate system on that, which is fairly important. So in Blender, delete everything and add in a curve object. Normally we add in a mesh, but I'm going to add in a Bezier curve, and this is something that we can edit in here and then take into geometry nodes and do a bunch of stuff. So in geometry nodes, I'm going to take this, make it a geonodes object, and we're going to take this group input, which is the Bezier curve, right? And we're going to do a whole bunch of stuff in here to output a mesh. What I want to do is I want to give it thickness, so it kind of looks like a strip. And for those of you that, are experienced with 3D software, you're thinking we need to extrude this curve in some sense. So let's try that. We take the input mesh, we try to extrude mesh, and we get a bit of an error. The error says unsupported type curve. What does that mean? We're taking a curve and we're using extrude mesh, but it's not a mesh, it's a curve. So, well, all we need to do is we need to use a curve to mesh operation, and it's still not going to be perfect, but check this out. Now we have no error. Nothing's being extruded because we are extruding faces, and this is just a bunch of edges, so I'm going to make it in edge mode, and you can see, yet again, it's glitching out. So there's a lot of barriers to entry to get this thing working. The reason that this is doing it, it's not because it's extruding in the wrong direction, it's actually using the normal coordinates as a basis for how to do this, so it's going to look at the normal coordinates. The issue is, if you think about the Bezier curve, it's basically 2 points, so you can only sample so many points in the normals, right? So first of all, let me make this higher res, and you can see that smooths it out a little. We can even bump that up to 60. It's going to kind of interpolate the normals, and it's not going to work. We need more points for the extrusion, right? So what I'm going to do is, before we do a curve to mesh, is I'm going to resample the curve, and I'm going to add more and more and more and more points. And the more points I add, the more accurate this is going to be. So let's do something like 200, and okay. So now we have more points to sample. We still have a bit of an issue. The normals aren't correct because we're doing some kind of weird conversion thing. So final step that you need to do is we need to bring in the original normal coordinates of the curve towards the offset. Okay, bit confusing, but follow along. We're going to capture an attribute for the resampled curve. We are going to capture what? The normals, so that's going to be a vector. And for this attribute, send it into the offset. And you can see now when we make it smaller, it's actually extruding correctly. Only thing we did here is modify which normals are being used for the calculation. Again, the count is going to give us kind of the resolution of this, which is useful because we want to control the amount of geometry. So I want you to picture this as the number of strips in some sense. And this is going to be our thickness. And I guess we want to have it be a positive number, something like that. One thing I'm noticing, though, is our curve is basically the side profile of this. It's not centered on the curve, if you know what I mean. And I would like it to be centered, right? It's kind of on the corner. I want it to be right here. So let's modify that as well. To do that, we just need to shove this towards the normal direction by half a unit. To do that, what I'm going to do is, let's see, we can do this after resampling the curve, is we can take the set position, move it based on, well, we already have the normal, but don't move it so much on the normal that it does that. Instead, we are going to scale this, so it's less of a thing. When it's 0, nothing happens. And as we scale up and down, you can see it's moving up and down the normal. It turns out that we actually want the negative amount so that you can see it's starting to get centered as we do this. What number is it exactly? Good question. Well, you're going to notice that we're extruding by 0.26, and coincidentally, almost exactly half of that looks like halfway. What that should tell you is that you just divide by 2, which makes sense since we want to go halfway. So I'm going to have an extrusion amount by, let's say, 0.3. We take that number, whatever it is, that can be a parameter we can control. We take it, and we are dividing by -2, since it's a negative number, and now this is going to be centered on our path. One other thing to consider is as we make this river longer, our segments are more spread out, and we want an equal number of segments density-wise. So I'm going to make the resampling relative to length, so that as our curve gets longer, it's going to add in more points and therefore more geometry. Okay, let's do a save. I'm going to call this river generator, and there we go. So that is making the curve into a thing. What we want to do now, what would be useful, is invoking a coordinate system on this, something that tells us where we are on the strip and how far along the strip we are, so that we can do all the material stuff. And then we can do like a bunch of giving it curvature or waves and stuff like this is probably what I mean. Probably. Who knows what I mean? Hey there everybody, and welcome to the Procedural River Generator tutorial series, where we are going to make a procedural river. If you haven't seen the other parts, check them out. What we have done so far is we have taken a curve, and that could be a custom curve that you input. Let me actually go to wireframe so you can see it. You take a curve, and it's going to turn it into a strip that, most importantly, we can control the thickness of, and it stays centered and all this, assuming you don't make it too crazy. If it gets crazy, you can just take this and like smooth out the curve. Okay, so we have that, and we intend to make a very fancy material that will kind of flow water along this. But to do that, we need to send information to the shader editor. We need to make a coordinate system that lets us create a texture coordinate space, that lets us flow things. So we need to know 2 things. One, I want to know how far along the river we are. That's useful information. Another one is I want to know how far across the river we are in some sense. So this could be our x coordinate, and our y coordinate could be the flow of it in some sense. So how do we bring that information to the shader editor? Well, first of all, let's make a material that lets us actually visualize things. So I'm going to make a material so that all our geometry has that material applied. Then in the shader editor, we can edit this material. So let's actually check that this works. So I'm in render mode, I'm changing the color, perfect. What I want to do is invoke a coordinate system, because you'd want something like UV coordinates, but we don't have them, right? So here's what we're going to do. For this, we need first of all to know how far along the river we are. That's basically asking how far along the original curve are we, right? Because if we know where the curve is, we know everything else. Okay, so what I can do is I can take this curve that we resampled and like repositioned, yada, yada, yada. We can take it and extract the spline parameter. So I'm going to use a store named attribute. This is a node that can send information right to the shader editor. What information do I want to send? The parameter, the spline parameter factor. This tells us, again, a number between 0 and 1, 0 being at the start, 1 being at the end, of where are we along the curve. I'm going to call this variable u1. Another thing I want for another store named attribute is how far this way across are we. And remember, this is basically proportional to the extrusion, right? So the information should be here. If you think about it, it's almost like we took the curve, this curve, and made like 2 of them and connected them. What this means is that if we set this strip to 0, and this strip to 1, we can interpolate 0 to 1 here, and everywhere, okay? Basically what this means, and I want to make sure, yeah, I didn't undo that. Basically what this means is that I can take the extrude mesh, take the top, and what top means in this case is what is extruded, the selection. That's going to be equal to 1 and everything is equal to 0. We can take that and store it as a U2 and connect that to the geometry. And make sure this is connected here. Okay, so again, U1 is telling us how far along the thing we are. U2 is telling us, are we at the original vertex or the extruded vertex that we are going to interpolate? Okay, let's visualize this. What we can do is bring in our attributes by using an attribute node. Let's use U1, and let's use U2, and let's see what that looks like. So U1 should give us a black and white gradient that goes along it. A good way to test this is you send this through a greater than node, and you can see the flow of this in some sense. So it goes from 0 to 1. The other one should give us a gradient going this way. Again, it works because our original curve has points set to 0, and the selection is only for the extruded points. It interpolates between 0 and 1. And another way to visualize this is using the greater than, 0 to 1. So we have a nice coordinate system. All we need to do is combine it into a two-dimensional thing. So I'm going to combine x, y, z. Which one you make x and which one you make y is arbitrary. Just be consistent. So what I'm doing here is I'm making x be the flow, how far along the river we are, and y be how far across we are. Just a convention, doesn't matter. The nice thing about this now is that we can map anything that uses a coordinate system to this strip. So I can use the this as the coordinate system for this, right? So now we have a checkerboard, and it's going to work no matter how much we extrude it. It's always going to work, and we can make it proportional to length if we wanted to. So it doesn't stretch this. And the way you would do that, by the way, is you do a division or a multiplication by the total length. So it would be something like this, right? So we store the factor, but we multiply it by the length, which does seem to do something weird at the beginning, but as you can see, this makes it even amount of, or no, we don't want the length, we want the total length is the issue. Do we have something like that? Curve length, we want it to be a constant. So this, there we go. Now it's going to have this be consistent, and I guess that is something that we want. Again, the advantage of this is we know where we are along the curve. What this means, and a river flows, what this means is that we can take this, add to the x-axis, add to the other axis. Did I get these flipped? I guess I did. We could do something like this, and it's going to flow along the curve. So if we can make this look like water, and we're going to talk about how to do that in the materials, then we can have this kind of flow along the river. So what did we do in this part? We made a coordinate system that looks like this, and that is useful for a whole bunch of things. So I want to just check if I got these mixed up. U2 is the flow, so I'm just going to reverse these. So our x-axis goes along the thing, our y-axis goes across it. So there you go, we made a coordinate system. In the next part, we could try adding waves or maybe a material or something like that. We'll figure it out. I think I want to add waves because that's also going to use this coordinate system since I want the waves to flow along here. Other than that, that is part 2. Hey there everybody, and welcome back to another Blender tutorial. This is part 3 of the Blender River Generator course where, so far what we've done is we've made a system that takes a curve and gives it thickness in some sense, and also it gives it a coordinate system. So you can see our x goes along the curve, so like this, which is going to be the flow of it, and our y coordinate goes across, right? And what we're going to use this for, now that we have a coordinate system, what is the point? We can take this and now do a bit of a fake simulation to make this look like a river. So that's what we're going to do in this part. And I also applied a simple material. So just by the coordinate system, we can already get this result just by moving around some polygons. So let's talk about how to do that. Let's generate some flow. So So far we have this. What I want to do is I want to use our coordinate system to kind of generate a flow. The way to do this procedurally is to take a noise texture that's going to dictate the height of the river and have the noise texture flow along the path, which will make the waves look like they're flowing along the path. So that's what we're going to do. To do this, we are going to separate this. So basically all these nodes here, I cleaned up a little, I clean up nice. All these nodes over here generate this. On this side, we have the material application, and in between is where we want to do the work. So one thing you're going to notice is that the extrusion, when we extrude it, it doesn't create lots of bands of geometry, which is something we need if we want to make waves and stuff like this. So I'm going to use a subdivide mesh to add those in. And you can see when I subdivide, we get more and more lanes of geometry. We also get more and more kind of columns, which is probably too many. So what we're going to do is I'm just going to take our resampling and multiply by 2 to make it half as dense and meek. And because of that, I think we can probably go up to 5 levels of subdivision. And again, this is a procedural in the sense that as we add more geometry, because this is length-based, it's going to update. Okay? What I want to do is anytime we manipulate the position of something, right, we want to generate waves in this case, we use a set position node, so I'm going to add that in, and we want to offset it by a vector that only uses the z-axis, right? We only want the waves to go up and down, not left to right, forwards, backwards, right? So we need to manipulate the z. To do this, I'm going to use a noise texture, which looks like it works, right? But the issue is if we were to use the coordinate system that this is using, right now it's using position coordinates, and we wanted it to flow along this, right? So I'm going to animate the x. It's not really flowing along the river, it's just going left on the x, right? So if I was to do something like this, where now our thing goes this way, there is no flow, right? It just kind of goes to the left. So what I want to do is use our coordinate system, and we can undo this. To do that, we have already stored U1 and U2 from before, so let's just bring those back and combine them. So we've stored named attributes, so now we can bring in named attribute. Specifically, U1 is going to be the flow, and U2 is going to be crossing the river. Take this, combine it into a coordinate system. By the way I just said take this reminds me of Sonic 06, where he's fighting Silver and he keeps going, take this, take this. Just reminded me of it. We're going to take the coordinate system and connect it to the noise texture. It's a little hard to tell, but this is now flowing with this, right? And let me make it a bit more obvious, right? So I'm going to extrude here. And what I'm going to do is I'm going to add on our flow axis, which is U1, and you can see now it is flowing along the curvature of this. It doesn't look good, but it works. So what I want to do at this point is make it look good. A noise texture, when you do this, you need to kind of average it out. So I'm going to subtract by 0.5. This is going to make some of it above the XY plane and some of it below, whereas before it was all above. And I'm going to take it and I'm going to scale it with a multiplication by 0.1, just so it's smaller. And by the way, a river should not be flowing up. Oh, well, it could flow up and down, actually. I don't know why I'm being so precise about this, but it definitely shouldn't curve. So you could, roll it over or something like that. Either way, we now take this addition and we make it relative to time, and we have flowing waves. Of course, it doesn't look good quite yet, but we can fix that. So I'm just going to modify my river a little, something like this. Bit of curvature so you can tell what's going on, and let's also move all of these to scale on the z-axis. And that looks pretty good. Name of the game now is kind of controlling this to look more and more realistic, right? So one thing is, I think our waves are a good height, but there's too many of them. So I'm going to take the noise texture and bring down the volume. So now we have kind of like a low density flow, something like that. And we can take this exact same system with, again, U1, U2, and we're going to add, the reason I'm doing this separately is I want this second level flow to be even faster. So I'm going to add time and multiply it by 2. So now we have 2 noise textures, one of them going twice as fast as the other. And I'm going to add both of these together. So same system, and then we add these together, you're going to see now we have kind of two levels of detail, especially if we bring up the scale. We have kind of the low frequency details. Let me bring this down to 0. We have the low frequency details, and we have the high frequency details that I think are a bit too high, but we can work on that. So something like 0.01 would work. So now you can see there's kind of like two levels of flow. Things we can do to make this look better, and we're going to play around with the settings in a second, but I want to set shade smooth. I'm just going to pick the amplitude of this until it looks kind of correct and not overbearing. And I feel like overall this is flowing too quickly, so we're going to take scene time and multiply it by 1/2, so it's going half the speed. And maybe we can make the flow from U1 go even faster. Something like 2.5. Just so we get a bit of variety going on here. I'm going to take this 0.04 divided by 2, and I think that's a good look. Again, this is something that we can modify at any given point. Other things I want to do is maybe up the detail on this, just so you can see what's going on a bit better. And if you wanted more resolution, you can do that, so you can actually see all this geometry, but we're going to add more detail in the shader, so no need to do that. And final thing for both of these noise textures, add a bit of distortion, which will create more of a water flow thing, right? So this is when it's 0, it's perfectly reacting, but when we add distortion, it swirls and all this, and it looks much better, right? I'm also going to add some distortion to this. And I think this kind of looks like a good flow. By the way, there's no reason that we can't add in a second curve and do some like weird stuff where we have a circular river, stuff like this. Of course, this has the issue of having a seam. At least it has a seam right here. But, you know, we can hide that and stuff like that. But you can do nice circular rivers and stuff like this. I didn't want to delete that. Okay, so there we have the flow. Next step for this tutorial is I just want to add a bit of the material so we can see what we're dealing with. Again, remember, we have our XY coordinates as our material. So what I'm going to do is just make a basic water material, principled BSDF. We're just going to set this to cycles, GPU. I'm just making some lighting. So I'm adding an HDRI environment because water is just reflective. So if it has nothing to reflect, we have a bit of an issue. So load in an HDRI. Probably an outdoors one, so it looks correct, right? You normally see rivers outdoors. And what I'm going to do is I'm going to take the roughness, bring it down so it's shiny, so you can see it's catching the highlights of the sun. You also want to take the transmission and bring it all the way up. And that's the basics of making water, right? You can also kind of make it a tiny bit like bluish green, stuff like that. But that's how you get a good kind of flow going. Do I want to edit this? You can make the river kind of like rough or very rough, depending on like what you want to do there. Do I want to do anything else with this to add a bit of variety? What we could do is I think a river technically flows the fastest in the middle, right? So if you imagine that we're like looking at a cross section of this, it should flow fastest in the middle and least on the sides, or maybe there's some curl on the side. We can try to incorporate that. Yeah, why not? So what I'm going to do is I'm going to take this time, and I'm going to multiply it by another factor. This one's going to be kind of a gradient going on here. So I'm going to use my named U2 attribute, which again is going 0 to 1. Let me actually show you. This is a U2. It goes 0 to 1. I'm going to take it, run it through a color ramp. So we want both sides to be black with a multiplier of 0, and the middle to be 1 with a multiplier of 1, so it flows fastest in the middle. I did not add a color ramp. So we're going to add a color ramp, make both edges black. So again, all I'm doing here is adding like an extra level of detail where it flows fastest in the middle. And I think we should just be able to take that and multiply it. Let's see what that looks like. So you can see there's a lot of flow in the middle, and then on the edges you can see it's staying very still. Now that's a bit of an exaggeration. We should probably make it have 20%. So I'm doing 0.2 speed, and 0.2 speed here. And it might help to ease this. And that just makes it feel more like a river. I mean, I will say that right now it's kind of giving me like molten lava vibes. So maybe a tiny thing we can do to fix this is I'm going to add, with a clamp, just some offset. So when we set it to anything above 0.8, it will look, because we have 0.2 on the endpoints, it's going to look normal. If we do a little less, it's going to be noticeable. And you could even make it so that one side is more stationary than the other, if you wanted to do something fancy. And don't forget, by the way, all of this is, you can make the river wider and all this and have a good flow. But it does look like very turbulent in a sense. I think I'm going to make it thicker just because that looks correct. And I think I'm going to add 0.5 just so it's not as extreme. Anything else I want to do? And again, this will all look better when we have a material. And I think this water is a bit too green. I'm going to bring down the saturation. So yeah, this is all going to look better once we have like more stuff going on. But this is a completely procedural water flow system. Let me just add a bit more kind of geometry and stuff going on here, visual interest. And it will flow along any path. By the way, we can also denoise the viewport so we can see what's going on a little in real time. I think that looks pretty good. Anything else to do here with the material while we're here? You can play with the index of refraction. I think IOR of water is 1.33. That's just a fact of chemistry and science and all this. And also, we could play with the transmission roughness if you wanted like murky water or something like this. You could make it metallic to make it shiny. But I think I'm happy with this. So let me just delete these extra vertices. And check it out. We have water flow on a arbitrary path. And I just want to try some other arbitrary paths just because it's cool. We could do a... what could we do? We could do an arc and make it, you know what, I feel like an arc is lame. I want to do well, we already did a circle, but I like the way the circle looks. Also, we could do a spiral and stuff like this. But I think this looks pretty good. You put some rocks on the seam here so you don't see it. And you got like a cool looking circular water thing. Either way, I think that's it for this part. So we took our coordinate system and made water flow along it. I think the next step is either adding some foam or starting to make some rocks. I'm not quite sure yet, but that's it. Hey there everybody, and welcome back to another Blender tutorial. Today we are on part 4 of the Blender River Generator. If you haven't seen the other parts, check them out. But long story short, what we have so far is we have a curve that makes a path that has a coordinate system, and we use that coordinate system to generate these waves that make it feel like there's a bit of a flow to this. And what I want to talk about in this part is kind of emphasizing the realism of this river by adding in, and I'll show you what we're making in a second, by adding in some foam on the sides, procedurally, of course. So you can see this foam flows on the sides. We're also going to add foam for the middle. We're also going to add foam for where there's rocks eventually. But for now, I just want to kind of set up our foam on the sides. And this looks super cool. I keep doing the circle example, but it works with any curve, right? It looks super cool with the circle because it lines both sides. So what I want to do is delete this and show you how to do foam. Let's do it. By the way, I hope you guys are enjoying the series. So the foam you could do either in geometry nodes or in shader nodes. I'd recommend doing it as a shader because we can do it fast and it doesn't have that much of a computation as compared to simulating this kind of, in a sense, with geometry nodes. So if we want foam to be on the edges, we want the coordinate system, especially the part that tells us how far across the river we are. That is going to be U2, if you remember, going across. What I want to do with this is I want to make a mask that says, here there's foam, here there's not. To do this, I'm going to start off with a noise texture. This is going to be the basis for our foam. Take the noise texture, make it high contrast so that there's clear areas that are black and clear areas that are white. White is going to mean foam. Take the scale, bring it up, and add a bit of roughness. This is the basis of foam. You can make it look better, and we will. Again, we want to use the coordinate system related to this curve, so I'm going to use this as the vector. And the cool thing about this is if we vector math addition, we can flow on the x-axis, so our foam actually flows. So I'm just going to do hash frame. If you didn't see what I did there, I typed in hashtag frame divided by 100 is going to give us 1/100th of the speed of every frame refresh, right? So if we're on frame 100, it's going to give us a value of 1, 200, 2, etc. Okay, so let's work on this foam a little. I'm thinking we're going to add some distortion, and I'm thinking we're also going to have this evolve over time because the foam bubbles collapse and form and all this. So I'm going to evolve this by a big number, a big divisor, because it goes super fast, by like 500. And that looks okay. To have this only be on the sides, again, we want to use the U2 parameter. So I'm going to separate that, or I guess we already have it separated. What do I want to do? I guess, so here's the idea, and I'm going to show you this first, and then I'll tell you what we're actually going to do. So what we want to do is isolate the center, or isolate the edges rather. So I'm just going to make 2 white points, and in the middle of the color ramp, which is the middle of the river, it's going to be black, right? We could do one here, and one on the other side, just to get, the edges isolated, right? This is what we're going to do, but it's kind of like too perfect, right? There's a nice crisp edge. So what I'd like to do is mix this with some noise. So that's why I'm not going to do this immediately. So instead, what I'm going to do is I'm going to take this, I'm going to make a new coordinate system that mixes this with a bit of noise, just to break up the pattern a little. So we're going to take a noise texture, and then we're going to feed it through the color ramp. And make sure the noise texture is also using the flow source, and set this to linear light. This is just a trick, one of the oldest tricks in the book. Connect this, view it, and now we should have it so, especially if we make this smaller, or I guess one thing is we want to separate the Y component. So instead of just taking the U2, I'm taking the Y component with a bit of noise mixed in, right? So I've taken this coordinate system and I said, hey, mix it using linear light with some other stuff. And this is going to break up our edges a little. I guess what I also want to do is also have this evolve over time. So I'm going to do another addition on the x-axis and have it flow maybe at a different speed than the foam, just so there's a bit of variety. So maybe 200. So it flows slowly as compared to the noise texture. Okay? So I'm thinking what we can do now is we just multiply these masks together, and in theory, we'll see in practice, but in theory, yep, that should give us foam only on the edges. And now the question is, 1, how do we incorporate it, and 2, how do we make it look better? Starting off with looking better, I want to add detail to our mask for the noise. I'm going to add a bit of roughness and a bunch of distortion. And you want to play with the scale. I'm not sure exactly what scale looks the best, but we'll find out. So something like that, big factor for big noise things, and it will naturally create some like lines and stuff that make it look more like intentional. I think that's good. And we want to incorporate this into our water material, and I think the easiest way to do that is to do it as a mix of color and normal mapping and roughness and all this. So what I'm going to do is I'm going to use this as a factor to mix the color. So I'm just copying my original color. If you didn't know, you can hover Control-C and then Control-V to paste. I'm going to have my foam be perfectly white, desaturated, and I'm going to have my water be a bit darker. Connect that. So now you can kind of see the foam, but it's still perfectly reflective in all this. What I want to do is have it keep the property. So I'm going to connect this to roughness, is what I'm saying. Black is the water, meaning that it's going to be reflective. White is the foam, which is going to have a roughness of 1. That makes it more visible too. And I think finally, we add a tiny bit of bump as a bit of a cheat. This will generate some normal mapping for us procedurally. And I think we connect that there. Make it maybe half the strength. And now we have foam that I think looks pretty realistic. We're going to work on it. That goes on the edges. What do I want to do? I want the foam to be more visible. So to do that, I think we just control our foam mask. So here you can see it's really starting to pop out. And you can make the foam kind of bubbly by breaking it up with the color ramp. So something like that. I'm also thinking our scale is a bit too, we need to make our scale bigger. So there's more dense foam. What else? I'm just playing with parameters until it feels right. I feel like the foam should probably actually be moving at the same speed as the thing, so let's have it go faster. So we're going to add, instead of 100, let's make it 50. Is this what I want? The foam's moving fast, but the mask isn't. So I'm going to move this to 75. And now it feels like it's flowing with it a bit more. Another thing we can do is I do want there to be foam in the middle, just not as much. So a quick trick. Oh, by the way, it should also not be transmissive, the foam. But this is a cool little render, so you can see kind of the modeling and all this. It shouldn't be transmissive. So I think what we can do is, unlike roughness, we invert this mask through the color. And this will make it so that most of this is white, in other words, transmission equal to 1, and some areas are going to be black, in other words, transmission equal to 0. And that should make the foam really pop. There we go. Now we can actually see the foam. And this begs the question, should we make it look a little less intense? Something like that. You can play around with the color ramps until you're happy with it. But remember, how far it is to the edge can be controlled with these sliders. And we can make it less intense, something like this. Just so it's there, but it isn't like punchy. And you can also make the middle have foam if you wanted to, which is interesting, right? So add a bit of a swirl there. So this is what it would look like if we had maximum foam. It would just like be crazy. I'm just going to do the tiniest bit amount of foam, just to add a bit of detail. Okay. Anything else I want to change about this foam before we continue? Strength. Probably should bring that down so it's less intense and we get our reflective water back. And I think that is it. Let's do, of course, the water test or the extension test. The extension test is where we just kind of add random curvature to this and see how it looks. I'm just making a river that looks pseudo-possible. And let's see what that looks like. So you can see it's flowing along the thing, and of course it should be. Yeah, that looks nice. And again, you can add more foam, in different places and control this. What I'm interested in now is making rocks with foam trailing behind them. I think that would look interesting. Let me scale this on the Z a little. This water is going uphill somehow, and then it's going downhill, which makes a bit more sense. Okay. Let me just delete these extra vertices now that we did the test. Whoops, I guess this one should be here. And I'm rotating this. Whoops. And here is our little river segment. By the way, there's no reason you can't like draw one of these. I think we should probably project from the XY plane. You can just draw a river that inherits these properties, which is kind of the point. So, anything else I want to do here? I don't think so. I think maybe we could make the foam like a little less intense, right? So I can just multiply this by, if it's 0, there's no foam. If it's 1, there's a lot of foam. I'll make it 75% strength instead of 100. And there you go. That is how we do the foam on the sides. In the next part, we're either going to talk about rocks or maybe some like bigger waves we can add as well. I'm not quite sure. We could have swirling pools and stuff like this. We'll figure it out. By the way, it's always good to test this with different HDRIs, different lighting conditions, just to see what you get. And just to test out if the normal mapping is too intense, which I think it is. But that's just a thing. Thank you guys for watching, and I will see you guys on part 5. Hey there everybody, and welcome back to another Blender tutorial. Today we are doing part 5 of the Procedural River Generator series, and I think maybe the next move is to add in some rocks. So again, if you haven't seen any of the other parts, I'd recommend watching them. But check out these rocks that I made. They're completely procedural, randomly scattered, and you're going to notice that the foam kind of reacts to where the rocks are. So if I play this, you can see it kind of looks pretty realistic, especially if you put it through a nice camera and all this. That's what we're doing this time. Where we left off, though, is we just made a nice curve thing that makes a river, and there's foam on the edges was the last thing we did. So now I want to add in rocks. And, you know, you could make a bunch of rocks and scatter them. I'm going to use a different technique. So let's do that. I'm going to close this over here. We want to make rocks, and we want them to be procedurally scattered. To do that, we need to do a couple things. One, we need to scatter our points, right? So we say, make a bunch of points, and then for each point, generate a rock. So what I'm going to do is I don't want to scatter based on this mesh because it's evolving. It's evolving over time. I want it to be consistent, so the rocks are stationary. They're not going up and down with the waves. What I'm going to do is I'm going to use this subdivided mesh to be our generator. Okay, so let's use a distribute points on faces using the subdivided mesh. Again, I'm not using the altered one, right? But we're going to use distribute points on faces. I'm going to use Poisson disk. What this means is it's going to generate points, but it's not going to have any 2 points be within, let's say, 0.1 meters of each other. So they're not going to overlap, so we don't have intersecting rocks. And I'm going to bring up the density. For each of these, I want to instance on points. So for each of these points, I want to generate an instance saying, use a sphere. And I know that's not a rock, but we will get to it. So let's make these spheres a bit smaller so that they're actually sized to our thing. Perfect. And then we're going to join it with our river. So you can see we have a loose rock system. Let's modify it a bit. I want the distance to be a bit bigger, 0.2, so that they're not intersecting. Maybe let's also, what else should we do? Should we increase the number of rocks? Something like this is pretty good. And we want to do as much as we can to these spheres to make them look like rocks. So first of all, let's randomize the scale so that they're not all the same. So what I'm going to do is I'm going to use a random value between 0 and 1, so it's uniform on X, Y, and Z for scale. I'm going to randomize these. At minimum, it can be 25% scale, and at maximum, it could be, or let's say at minimum, it could be like 0.4, and at maximum, it could be like 0.8. And this is telling me now that I want more rocks now that they're smaller, so I'm going to bring up the density, something like that. Next, to make these look like rocks instead of spheres, what we can do is we can distort these until they kind of look jagged and all this. So here's how I'm going to do that. We have a bunch of spheres instanced. I want them to be converted into real geometry, so they're not just instances now, but they're real geometry. And for each of these, I want to manipulate the position, so we always use a set position node, and I'm going to offset it by some randomness, a noise texture. You're going to see it's going to bring everything up to the corner and all this. This is because, on average, noise texture adds a number between 0 and 1, which on average is 0.5. We need to subtract 0.5 to even this out. So now these are centered. By the way, we should be using color, not factor, so it's different on X, Y, and Z. So you can see now these things are centered, but it's a bit too intense. So I'm going to scale this effect by some amount. So you can see we start off with spheres that we distort until they kind of look like rocks. Okay? To make these look more like rocks, there's a couple things we can do. One, we can play with the detail As we bring up the detail, it's going to add more kind of sharp things going on with our rocks. Another thing we can do is mess with the scale. So you want to ask yourself, how jagged should these be? And maybe a bit of roughness. And those kind of look like rocks. We can play around with it a bit more. But let's set shade smooth. Now they're smooth rocks. And let's play a bit with the distortion. So I feel like these are a bit too big, some of them. So let's have them be a maximum of 70%. And yeah, I think that looks pretty good. By the way, the more resolution we add to these, the more the noise can affect it. Let's do a bit more randomization. I'm going to randomize the rotation. So I'm going to use a random value. Whoops. And this will, oh, I guess random rotation doesn't really matter if we're going to then distort it. So I guess if you wanted to do a random rotation, you could do a random per island here. You know what? I'm going to skip that step since it seems a bit more complicated than I'd want it to be. Okay, this is a bit too intense. I'm happy with that. So we have rocks. Let's see what this looks like in rendered mode. Yeah, it looks much nicer, doesn't it? And you can see the rocks are stationary, so the water goes up and down and all around. Maybe we could have rocks be a bit smaller, so I'm just playing with the look. And we can have a higher density. And remember, we just changed the seed value and we get a different distribution of rocks. But now, let me make the material for these, and then we will do the foam that reacts to this in the next part. So for the material, what I want to do is I want to set a material. This is going to be separate than the river. So we have the river material, the water material, and now we are going to have the rock material. So right now I'm having this use the water material as well, which does some weird things, but we're going to make its own. So we're going to make a new material. We're going to call this rock. We can call the previous one water. So now both of these are using water. I'm going to swap this to rock. So you can see, again, original thing's using water. This one's using rock. And for the rock material, let's make it look like a rock so we can get rid of all this. Starting off, I'm just going to use a principled BSDF. So we just have these white rocks, and you can see this thing is now responsive to the color. A rock is basically a mix of color that looks random and normalized, as in there's bump and all this. And we can also do something where the rock is wet on the bottom where it touches. We could do all of these things. So let's start off with coloring the rocks. So I'm going to use a mix RGB to pick two colors, and what's going to drive the factor is going to be a noise texture. So I'm going to use a noise texture, bring up the scale, and make it high contrast. So I'm using this color ramp so we can actually see what's going on here. So you can see here we have our noise. I'm going to make it smaller. I'm going to add in detail. That's a major thing. If you don't add in detail, it's not going to look like a rock, right? Add in that detail. Add in that roughness, and you can already see it's kind of looking very rocky in a sense. And we are going to use this as the factor to pick two colors. So one of them could be like a dark reddish kind of thing going on, and the other one can be a much lighter, also reddish thing going on. And we can play with these colors. Put this in the base color. Okay, already that kind of looks like rocks. Again, when you put it through the principled BSDF, it's going to look a lot better. I think a major thing that's going to make this look better and not like clay is we send this through a bump. So we're taking our noise mask and turning it into normal information. Put that in there, and now we actually have like fake detail, as you can see. And I think that's pretty big. If anything, let's bring this down, just so we have a bit more of a gradual fall off. Okay, these look like rocks. If anything, this is a bit intense. Bring that down by 25%. And I think lastly, what could really sell this, as I said, is having the roughness be low where there's water. And otherwise, we could have it be high, so it's not super reflective. How do we know where this is intersecting the rock? Good question. Well, we have a node exactly for this, ambient occlusion. This is going to tell us where there's a lot of ambient occlusion. In other words, where is it going to be intersecting our river? And you can't see it yet, but when we bring up the contrast, you can see it's not only is it showing where it's touching the river, but it's also going to add in like pockets of high concavity where water could have been trapped. And let's see, do we want to change any of this? No, we do not. Okay, so we're going to do something like that. By the way, you can use the normals to drive the wetness map a bit more as well. Why not? We're going to use this, and we're going to say where it is black, have low roughness, perfect, and where it's white, have high roughness. Beautiful. Connect that, view it, and now you can kind of tell that this rock is very like rough, diffuse, but it's very shiny on the bottom. To really emphasize this, I can mix in the color black. So I'm going to multiply the color black and say, show this color. So, you know, we can make our rocks lighter, blacker, and all this. But use this ambient occlusion as the factor. So what this should do is darken. No, we want to reverse this, actually. There we go. So now it's going to be multiplying the most where there's ambient occlusion. And you can see here's the before and the after. And that's just going to make them look nice and dark and slippery and like they were actually wet. So I think this is looking pretty good. What else could we add to this? There aren't any other properties of the material that I think matter, like IOR, transmission, and all of this. If anything, it's really about adding foam that reacts to the river, I believe. But I'm trying to think if there's anything I'd like to add in here. I think these rocks look pretty dang realistic. Again, the normal might be a bit intense, so I'm going to bring that down. And I'm just trying to think before I end this one if there's anything I want to do before I add in foam. I just want to mention as well, this is all, of course, procedural. You know, it generates new rocks as we extend it. And as always, I like to do my circle test, because it just looks so cool. Yeah, that looks fucking dope. Okay. Anything else I want to do with this? We could chop off the rocks on the bottom, but ideally you're putting this on terrain so you wouldn't see it anyways. Let me scale this down to 0. Yeah. I don't know if there's anything else I want to include here. I feel like I'm just like buying time or something like this. I think that's it. Okay. So, we made rocks. In the next part, unless I'm forgetting something, we are going to add in foam. So let's do that. Hey there everybody, and welcome back to another Blender tutorial. I think this one's going to be the finale of the Blender River Generator course, but there might be a bit more. So I'm wearing the suit because I think it's over, but it might not be over. In the last part, we generated rocks. So if you haven't seen any of the other parts, make sure you watch the whole series because this is going to be building off of that. But we made the rocks, and what I want to do now is the foam that we have on the sides here, I also want to extend to the rocks. So there should be foam around the rocks and a bit of a trail behind each rock. So we somehow need to do that all in the shader. Starting off with the foam around the rock, kind of like the boundary of it. This is actually super simple. So we're going to go to the water material, and remember, we've already I've modified it a little, but we have made this mask for where there's going to be foam, so that's what this is. We just need to modify it so that it's kind of on the rim of each rock. How do we know where the rim is? Well, it's the same thing as in the last tutorial. We can use an ambient occlusion node. So I'm looking at the ambient occlusion. I want to say make it white wherever there's a lot of ambient occlusion and black otherwise. So I'm going to use a color ramp to flip these, and then all you have to do is bring down the black value. And you can see we've isolated the areas where the rocks are intersecting, because that's where there's a lot of ambient occlusion. So a useful little trick. What we can do is we can add this into our mask and then multiply it by the noise thing. So again, we have our like noise that's everywhere, and now we have our mask that shows where there's going to be foam. You multiply those and it's going to show up in both places. So now you can see, it's a little subtle, But if I disable this, there's no foam around the rocks. If I enable it, there is foam around the rocks. And we can make it more intense by playing with the sliders. So now there feels like there's a bit more interaction, right? Like the water's hitting this in some sense. Second of all, I want to make a trail behind the rocks. And this is going to be a bit complicated because we somehow need to have a rock detection algorithm that isn't based on ambient occlusion. So here's what I'm going to do. And it's a bit of a kind of a neat trick. So let me just close this panel a little. What I'm going to do is I need to know what area is behind this rock. A good way to do that is to have the rock flow along the river, right? If this rock goes down the stream, then we know where the foam should be. It's where it's going down the stream. If that doesn't make sense, check this out. We're going to use an extrude mesh. We are going to use our rocks and extrude them. So let's see what that looks like. It looks like a disaster. So you can see it's just making our rocks bigger. But what I want to do is not like make them extruding bigger and smaller and all this, but I want them to shift down the stream. So if we know our original curve and we know the tangents of it, in other words, which direction is it flowing, we can extrude along that direction. So going back to the curve here, where remember we have a curve, we can use another capture attribute to capture the tangent. Again, the reason I'm doing this is I want to bring the tangent deeper into the process where we can extrude along the tangent. In other words, shift it. And I'm bringing this all the way to the extrude mesh into the offset. And you can see now the rocks are flowing down the stream, right? So if I just do a bit of a negative value, you can see the rocks are flowing a little. If we extrude the edges, this is going to let us kind of like extend them in this sense. So it's almost giving us the trails. And if we now scale elements, so this is just a neat trick that I'm like, how am I going to detect trails? You don't want to use geometry proximity because you only want the stuff behind it. So I came up with this. We're going to scale elements on the top and pinch these down. So you can think of this as like we're generating cones that go downstream from the rocks. And yes, at this point we do use a geometry proximity. So we're saying, look at how close we are to this geometry and send this distance into the shader editor. So I'm going to store named attribute, and I'm going to call this distance. So in theory, if I now view, so these rocks, these extruded rocks are just made for the calculation. For the final viewing, we're still going to have our normal rocks. But in theory, we'll see if it works in practice. We can now take our attribute, type in distance, which is the thing we store named attribute for. And I guess we do need to do this as part of the main chain, so I'm going to store named attribute here. If we look at the distance in the rendered view, you can see nothing, which isn't ideal. Let's see. Do we want to switch one of these? Why is it not working? Somebody tell me. Okay, I think we put the store named attribute again in the wrong spot. It should be on the river object, not on the rocks. So let's see if that changes anything. So I'm going to do this. And now you can see we have a distance function that shows the trails of these. Again, I want to do a bit of an inversion. Luckily, I figured it out. I was going to be like, oh, do I have to re-record this tutorial? That would suck. I'm going to bring this black down so you can see these actual trails, and it is going to be kind of a tight fit. So there is our trails. I don't know what I was saying before, but I want to take these trails and mess them up a bit in the same way that we added distortion to other parts of this. To do that, luckily in our geometry proximity, we have a position kind of attribute. And if we take this position and do the same kind of noise trick that we've done before, so I'm going to mix this position with a kind of a distorted version of it with the noise, luckily we should be able to kind of mess with this. So when this is set to 0, we have our trails, and as we add a bit of distortion, you can see it's breaking up the pattern, especially if we bring up the scale to something large with a bit of detail. Let's see what this looks like. So we're just kind of making our trails a bit choppier. We take this, we add it to our foam mask. So now, again, this is saying where there's going to be foam. And now you can see there's actually trails of water or foam trails behind the thing. I'm happy with that. Maybe something to do is have this evolve over time as well. So I'm going to do a hash frame over 100. And let's see what this looks like. Yeah, this way it's nice and evolving. And maybe we can make it a bit slower. Over 300. And yeah, now we have a foam selected where we want it. So it's going to be on the rim of the rocks and on the trail behind. And remember, all of this is based on our extruding function. So if we extrude it less, if I can find where that is, if we extrude it less, the trails are going to be shorter. Or sorry, they're going to be longer if I do it in that direction. So here I'm making the trails longer. And here I'm making it shorter. And maybe something to consider is to randomize this. So I'm going to do a random value between -0.3 and 0 so that they don't all have the same distance. So before, after, maybe it changes something. I don't know. But there you go. That is kind of it. If I think of other things to do with this river to add realism, then I will make a part 7, I believe. But I'm pretty happy with the way this looks, and I'm just doing the circle test because I always love the way this looks. Yeah, so now that our stream is going, maybe it's easier to see in solid view. It is getting glitchy, not gonna lie, but you can see it's going this way. Okay, so I think I'm happy with this, kind of an awkward ending, but what are you gonna do? Thank you so much for watching, and if there's more, leave it in the comments, like, oh, maybe there should be leaves going down the stream or something. Let me know, and I will make sure to incorporate it. Other than that, that is the end of the tutorial series.